So derivation of formula for potential energy of simple harmonic oscillator. We know a particle or body executing simple harmonic motion is called simple harmonic oscillator. So let a particle of mass m executing simple harmonic motion along the line BOC. So here O is the mean position, and so my A is the amplitude, B and C are extreme positions. So we know that in simple harmonic motion, restoring force capital F acts opposite to displacement y. So for the displacement in the simple harmonic motion, the particle has to do some work against to the restoring force for the displacement y. So for the displacement y, so the particle has to do some work against to restoring force. When the displacement, displacement at mean position is a 0, then restoring force acting is also 0. When the displacement here it is a maximum, then restoring force acting is also maximum. So when the displacement is a 0, restoring force is a 0. When the displacement is a maximum, the maximum displacement is a y, and restoring force is also F. So then average force is given as, so initial force 0 and final force F by 2, that is F by 2. So work done by the particle against restoring force is given as displacement into average force. So displacement is a y and force is, average force is F by 2, but from Newton's second law of motion, F is ma. Substitute this here. So we can get y into ma by 2. But in simple harmonic motion, we know that acceleration, magnitude of acceleration is given as omega square y. So then substitute this in the place of acceleration, then we can get this is, so W is equals to m omega square y 2. But here work done by the particle is stored as potential energy. So work done is stored as a potential energy in the particle. So work done equal to potential energy. That is why potential energy equal to half m omega square y. So this is the formula for potential energy of the particle executing simple harmonic motion, that is simple harmonic oscillator.